Okay, attendance for today. Set the password. Okay, it's my see my face. Okay, today we're going to talk about para model as for example, when we talk about cloud computing platform and so on, where one very important things is they are can be executed in the environment which is distributed, and they can run in parallel. They can run concurrently. So before we go to the technology, how they can run in concurrently, we like to see the basic concept of parallelism and how we define, how we measure the efficiency, the speed up, and whether the program is efficient or not, and so on. The attendance, sorry, there's something on the chat. The attendance is not active. Okay, okay. Let me check. Oh, attendance replay. Oh, I need to take or what? I think I do something wrong with. Let me change the setting. Allow student to record on attendance. I set from what time to what time? Oh, oh my God. Can you take your attendance now? I think yes. Okay. I will delete the rest and then recreate. Sorry. So today we're going to talk about the social action. Action. Now is it okay the attendance? Now can, right? Okay. Okay. For the overview, we like to talk about the parallelism, writing parallel program, and issue in designing parallel program, performance. Okay. So first, what do you understand about parallelism? Have you executed something in parallel before? You can type the chat. Have you executed something in parallel before or used parallel program before? And give me some example of thing that you can execute. Yeah, system working at the same time. I've been recording already. Record. Okay. Oh, my face is gone. Some more. One more time. How to make this go? Bring it forward. Show me in front of presentation. Still massive. Okay, give me example of the program. What the upload the recorded you directly can see from the video itself, from the link. When you access the recorded video, is automatic. Don't need to upload anything. Okay. Example, you go to this one. Okay, lecture. Then webback lecture. Then you find the recorded one. This is a meeting. You go to like recording, right? And then you search for those recorded virtual meeting, past meeting. Okay. For those past meeting, you should able to play it. There's a recording. Okay. View recording. You come here and view recording. Okay. Automatic there. Understand? Go to Monday lecture. You click recording automatically there. Okay. Because once I recorded, you can view back. No issue. Okay. Understand? Get it? Understand? Give me 2. Okay. So now my question is, give me example of the program that you execute in parallel or any application that you use. They are run in parallel. Have you execute any program that run in parallel? Example? program that run in parallel to hack the password using try every password and then see whether can get it. So please give me more example. Anyone? The thing that you run in parallel, any example that things are running in parallel? How about you run a window? Is it a parallel program, window OS? Is your window OS is parallel? Can run in parallel? Yeah, window OS can run parallel. Why? Because they allow multi-thread running on multi-core. So you can do many things at once. You can read, you can type something, you can watch WebEx. Okay, you can watch YouTube while you can do Microsoft Word editing, prepare your report. Okay, these are parallelism. How about something you do? Run deep learning. Is it deep learning is run in parallel? Deep learning. So deep learning also run in parallel. For example, you use GPU. Okay, run in TensorFlow, can run GPU, can also run in parallel. What else thing that run in parallel? What else thing can run in parallel? Have you written parallel program before? Anyone? Have you written parallel program before? What kind of program that you have done before in parallel besides multi-thread? No? Yes or no? If you have written the parallel program before, including multi-thread, give me 1. If you never do parallel program before, give me 0. So most of you never written parallel program before. Okay, so it's interesting, very interesting to write parallel program, and it will make use of your infrastructure. If you write your program in sequential, even though you have a supercomputer, it cannot go very fast because everything execute in sequential. So you must have a library or that can make use of multi-core or multi-CPU. Then only you will benefit from that. Okay. So I close the chat. The chat here. Okay. The bottleneck. What's the bottleneck? Sequential program cannot leverage on advanced machine architecture such as multi-core and GPU. Execution in parallel using N machine may have N speed up optimization. So if, for example, your program, old program, and you have a, let's say, cloud architecture, or using you have a very a lot of GPU and so on, you execute your old program, which is written in old language, and didn't make use of multi-core like multi-thread library, and even though you upgrade your machine, your program still running very slow because it have a bottleneck. It execute everything one by one in sequence. Okay, that's the problem. So sometimes is your you have a good hardware, but your software is not up to date, then your whole thing is still very slow. So you must able to leverage on the hardware. Okay, and there's currently there's one thing that's popular in the DevOps environment. DevOps stands for development and operation. Yeah, have you heard about infrastructure as a code? Have you heard about infrastructure as a code? Anyone? If you heard before, give me one. If you not heard at all, give me 0. Infrastructure as a code. Okay, 0, 1%, 0. Never heard of it. So actually, it's a very interesting idea. If you don't need to modify your program and so on, but you tell the program you have how many resources that you have, how many CPU, how many instance that you want to run, then it can make use of all the infrastructure. This is a new idea. People want to leverage the software, leverage on the hardware, because your hardware might change, especially on the cloud, and then you can redefine your infrastructure. So there's a thing called infrastructure as a code, and I think one of the popular uh, tools that available is Terraform. Okay, you can Google. While I'm talking, you also can start Google, so that you can learn, for example, infrastructure as a so as a service. Okay, these are infrastructure as a code. Okay, Terraform is one of the popular popular tools and so on, but there are others and so on. Okay, so you can look at it. These are for example, is a new trend. It's a new thing that in the cloud computing infrastructure as a code. Okay, Terraform is one of the popular one. Okay, that people use. You can also use it in AWS. Okay, so these are something that new. So these are example, and then also there are many concepts for virtualization, and people also like what your network, your infrastructure can software defined. They call software defined. So actually, infrastructure as a code is concept of software defined. So software defined network, software defined infrastructure, software defined something. So this is this. Okay, like Google Colab. Okay, like a Google Lab for Python component compiler. Okay, Google Lab, sometimes Python compiler using Google Lab, I'm not sure, but that one I think is a serverless. Mean you don't need to specify server, and then you can use it. Serverless concept. Okay, so it detached from particular server, so you can run your Python on this one. This is something like what Lambda in AWS. Okay, uh, Google Lab for Python compiler. I'm not sure that uh, but I don't think it's the same concept. Infrastructure as a code. Okay, it's not at the programming level is how you define your resources. Okay, how you define your resources. You look, have a look at the Terraform. Okay, Terraform. Okay, it's more on the Terraform and so on. Okay, the execution in parallel using N machine may have N speed up optimization. What mean speed up? Mean, let's say for example, you have one machine that execute required to take 10 seconds, okay, and you use two machine, then it divide by 2, then your execution is 5 seconds. So you have speed up is 2 times faster, right? If you are using let's say 5 machine, then you have only 2 seconds, okay? So divide by 5, you have 2. So you are 5 times more faster than you use one machine. So these are defined as speed up. So if you use more machine, then you can have a faster speed up. So if you use two machine, okay, you have 5 seconds, then your efficiency is 100% because you use two machine, you have two speed up, 2 times speed up, okay, faster, then your efficiency is 100%. Okay, so this concept of speed up. Okay, when new terms, then you will learn new things. Okay, so the burden is on software. Okay, so it's not everything is magic. You write and then you don't need to do any optimization. Then you buy a better computer, then your program can run faster. This is not true to many old application that written in traditional languages. Okay, for example, you write things in C language, or you write things in all languages, and then you upgrade your machine. Not necessarily it will have a faster speed up. Okay, because I say bottleneck, the old way of executing things, your program, yeah, it's like you have um, better equipment, but your engine, let's say you are you buy a car, okay, you have the horsepower is still the same, and then you renovate your car with a nice accessory to make it new paint and so on. Your car cannot run faster because the engine is still old. Okay, so same software can detect your performance a lot. If your software doesn't take advantage of the latest CPU or latest multi-core, the way it execute is not in parallel, so it won't help you a lot. But today there's come out a lot of library that you doesn't need to change your code, but you run on on the faster machine or more core, it can scale up. This is a new way of thinking, mean you doesn't need to recompile your program. Okay, you don't need to rewrite your program, and then your program can run faster, but you need to write using a parallel library, using a library that can discover the resources, and then they can scale up. So this you need to know. There are in the market, there are many programs that are able to do that. Okay, so this is also something. For example, for multi-thread, if you have more core, then you are using able to scale up using multi-thread. You're able to do so, that you run on 2 core or you run on 8 core or 16 core, then your program can run faster because it can spawn more thread. Okay, using some old one using a pragma function. Okay, and it will define, then it very easy, then it will take, depend on how many core, then it can do a loop based on number of core, it can automatically spawn. Okay, certain program like MPI, you can put it as a parameter on the number of CPU that you have, then it can scale up as well. So now today's there are parallel program able to scale up if you have more resources. Okay, but if you not write your program in that way, okay, then you are use library, sequential library that cannot scale, then your program will not run faster. Okay, you have to understand this. Okay, so there are basically two concepts. Okay, one are using shared memory. So shared memory means it still run on same physical machine that have a large pool of memory. Then you can run your program. For example, multi-thread. Multi-thread, you can have thread memory and your process memory. So if run on the same process, then you can share the memory from different thread. Your child thread can access to your parent process. Okay, so these are called shared memory program. Okay, but for example, let's say you execute your program in a different computer, they have different memory space or process space. So each process space or memory space, they are not the same. So if you are using a wrong memory address, then your program it will not work, and then the program also will not allow you to access the data inside any memory address except you are authorized run on in the same process space. Okay, so if for example you run a program, for example last time when we compile C program in a Unix environment, and sometimes when we play with array, okay, array, then and we are using a wrong address, the member, for example, the element the outside the scope of array. For example, your array is only have 9 member, and then you go to access 11 member or 12 members of your array, then elements, okay, then it will give you call dump error, execution error. During compilation, you don't have a problem, but you use the wrong pointer and so on, and then you try to access the content inside the address pointer, then you will have a segmentation fault, call dump error. These are example of your program try to violate the memory space, it try to access it. Okay, so it cannot. So in that kind of environment, you require to write your program to exchange information through for example through certain port. Okay, and this port carry out through uh, different protocol, communication protocol, such as UDP and TCP. So through socket, then it passing this message from computer A sent to computer B, and it represent, and it how to say, it pack it and then unpack it in the other sender and receiver program, so that you can have a value of the variables. Okay, you cannot directly access the variable in your computer because the memory problem. So what you need to do is actually put it inside the message, send it over using sender receiver, and then you will get it. So this is a very primitive using socket, but they will have a higher level, okay, using different programming things that we can look into that later or in the next topic or next chapter. Okay, so parallel program, writing a parallel program. How do we write parallel program? There are two ways of writing parallelism. One is called task parallelism. Another one is called data parallelism. So what is task parallelism? It's a partition various tasks carry out solving a problem among the core. Okay, so for task parallelism is you spread. For example, let's say I'm using human. It's easier, and later we change it to computer and program. Okay, so for example, let's say if you are using a task parallelism, let's say you are open one restaurant, and then you are you have 10 employees. Okay, so you divide their, each of them have different tasks, different job. Okay, for example, you have three waiters. Okay, three waiters. So the first one only clean the table. Okay, clean the table, put tablecloth and so on. And then second one is taking the dishes and serve the customer. Okay, and third one maybe welcome the customer and taking the order and so on. So you divide them by each of them only do specific job, and then they can divide their work and do it in parallel. Some are cleaning the table while the other one serving the customer, and serving the customer by taking the dishes or taking orders. So all are running in parallel, but they are performing different tasks. Okay, these are called task parallelism. And for example, the last week we talked about orchestra. So when talk about the scenario example of orchestra, each of them play different instrument, but they are try to achieve the same goal. Okay, same song, but playing the different instrument. This also called task parallelism, because we divide each person doing specialized job, doing different tasks, but all of them can do it in parallel, concurrently, but they are just run in different job. Okay, so another example is like in the manufacturing, you have different assembly line. Okay, after the first line, then you pass the product, go to the second assembly line, and then go to the third assembly line. So the product, the raw material or semi-finished product, it go from station 1, go to station 2, station 3, station 4, line 1, line 2, line 3, line 4, and then it will have more and more parts assemble during that one. So from assembly line 1 go to assembly line 2. Okay, then we call it pipeline. So A go to B, B go to C, C go to D. Okay, so these are called pipelining. But each of the stage, they are performing specialized tasks. So these are called task parallelism. I used few example already. Okay, so we convert into program and computers the same one. Okay, so you can, for example, you have a few program, they are running on different server. So for example, server 1, you are executing it mainly to do the database. So you have a database running on server 1, and then you have another computer, they are running on the web. For example, the web server that serve the HTTP request and so on. And you have application server run in middle while the HTTP request come in and so on. You use the HTTP protocol, for example, REST protocol, HTTP GET, HTTP POST, HTTP PUT, and so on. So you use the this protocol, and then you are calling certain program on the back in order to get the result and also access to database. And this program also run in different computers. So example of this, they are run in parallel. Different program keep on have serving the query, serving all this one, but they are running different tasks. Yet the whole system need to have all the component in place so that they can run. So these are example of task parallelism. Okay, example of task parallelism. Whereas data parallelism is also very popular, is actually you partition the data used in solving the problem among the core. So the program is the same program, but different data set. Okay, so each core carry out similar operation, but using different parts on the parts of data. So example, I'm using the example of human. Okay, so in that restaurant, for example, same thing, restaurant. If you use the data parallelism, so every waiters do the same job, but you have three waiters. So the first waiter serve table 1, second waiter serve table 2, and third waiter serve table 3. But they are doing the same job, taking the order, serving the customer, and cleaning the table, cleaning the table. So they have 3 jobs to do. All of them doing similar jobs, but they are serving different tables, serving different customers. Okay, so you can have this thing, data parallelism. But of course, data parallelism here, they are performing only particular tasks. Okay, for example, each of them serve customer, then you easy to understand. But they can carry out a series of similar tasks as well. Because when you write a program, it's not one instruction only. You have tens of instruction or 100 instructions. Same like instruction can represent actually one subtask or one steps, carry out one steps. So if you go verify, actually they are carry out different a series of tasks, but they are carry out similar tasks. Okay, so these are example of data parallelism. And in factory, same. For example, one assembly line, you have 10 operators, they are doing similar tasks. Okay, and but yet they are one doing part one on a different component different parts okay. You have many parts going, but each of them doing the same job on different parts. So these are also called data parallelism. I'm using that for example, in organization, in human. So in program, when you do data parallelism, for example, in the deep learning, okay, you have similar program, whether you are running CNN, convolution neural network, or you run RNN, recurrence neural network, you run for example, deep belief network, and so on and so forth. So, and you have many data sets, okay, thousands or millions of data, okay, each of them. Then when they run through this GPU, well, your GPU got many core, right? Because stream processor, then all this data run it as a different data stream on different GPU core. So actually, it do the same program running, but using a different data set. So these are example of data parallelism. Okay, using a lot of time for rendering and also simulation. For example, you want to simulate the liquid crystal, a lot of scientific application. You want to test on different temperature and see how it react, or different kind of environment, how it react. So they prepare data with different parameters, okay, but same kind of data, but different kind of value on certain values, okay. So they run it on different computers, okay. Uh, environment one on dataset one, environment two on dataset one or dataset two. So they can run it, and then they run it on different computer, then they do data parallelism. Okay. So do you understand task parallelism and data parallelism? If you understand, give me 3. Okay, very good. Okay, so you understand, huh? Okay. So example, okay, I have 15 questions, 300 exam. Okay, 15 questions, 300 exam. Okay, and I have 3 person help me to mark it. Okay, teaching assistant 1 and teaching assistant 2 and teaching assistant 3. Now, for example, if I want to do data parallelism, okay, data parallelism on this, I have.
没有声音了。
Can you see me and hear me? Oh, okay, okay. I think network problem. Sorry, network problem. Okay. Start again. Um, let's say you have can you see my screen? Yes. Okay. So now I give you this question. I have 15 question, 300 exam, okay, and three assistant help me to grade. Okay. So now you can think of this person is like a server. Okay. Now I want to do data parallelism. Okay, so how should you do it? Data parallelism, 15 question and 300 exam. How can I divide and conquer? How can I divide and conquer? Okay, so anyone? Okay, so someone say something. Let me read. 5 question, 300 data parallelism. Okay, so the first one, Zhao Jing say 5 question, TA1. 5 question, TA2, 5 question, TA3, 5 question. So these are called data parallelism. And then Maina, Uma say 300 question divide by 3. So each of them take 100 question, 100 script to mark. Okay, which one is correct? Okay, the first solution is correct or second solution is correct for data parallelism. And others, there are two proposals from your classmate. One is give each teaching assistant 5 questions to mark. Another one is give one person 100 script to mark. So you can finish both answer can you are doing parallelism, but one is belong to task parallelism, one is belong to data parallelism. So which one is the data parallelism? Is it the first one is data parallelism or second one? Give me the answer. First one or second one? Second one, type 2. First one, type 1. Okay, the rest, only 2% answer. Data parallelism, is it the first solution or second solution? Just now proposed by your classmate. One is give each one 5 questions is the first solution. Second one is give one person 100 script to mark. So first or second? First, give me 1. Second, give me 2. Data parallelism. Okay, the answer is correct. The answer should be 2. Data parallelism, because each of them doing exactly the same task, marking 15 questions or marking 15 questions, but they are marking different script, different data set. So each of them mark 100 script. So when you do that, it's called data parallelism. But if you do task parallelism, each of them you assign to do different things. For example, the first person only mark first question up to the 5th question. So he marked 300 scripts, but only mark first 1 to 5 question only. The second person mark from 6 to 10. Okay, 6 to 10, 300 scripts. Okay, and the last one mark from 11 to 15, 300 scripts. So these are called task or data parallelism. Task or data. Okay, this one is called task or data. Task. Okay, correct. So now you know the differentiate this one. So when you do programming in parallelism, then you must you need to think of this idea. This idea very good. You know, this idea very good for doing parallelism, and you actually can go further. You can do hybrid as well. Hybrid mean you also combine the task and you can combine the data. Understand? You can do hybrid. Means certain people, they are doing same task, but certain people doing different tasks, and you do hybrid. Example of hybrid. Okay, example of hybrid is in the factory, in manufacturer. So manufacturer, you employ for example, certain operator, they are do same task. So same task, you employ them, operator doing same task. And you employ also engineer doing different tasks. You also employing those that do maintenance and so on. So you have a group of person doing same task, another group of people doing different things. So a group of people that do same task, actually you are doing data parallelism, but you also have different title, different position. And when you have different title, different position, engineer, manager, and so on, then you are performing task parallelism. So you can combine the two. Mean you don't employ only one position, one person only. You have one position, you can employ more than one person. When you employ more than one person, they are doing same task, and you employ more than one person, actually you are doing data parallelism. Okay, so you can have hybrid model. Most of the company factory, they are using hybrid model. So when you are real in you come out a solution, your solution also is a hybrid model because of task parallelism is easier. Because when you design your component, when you do, for example, what we call service-oriented architecture, mean when you design your thing according to service, okay, you are doing data parallelism or task parallelism, service-oriented architecture. You provide according to service. Is it task parallelism or data parallelism? From the concept service-oriented architecture. You know what means service-oriented architecture? SOA. You didn't know, you can Google, Google, make this thing in how to see, service oriented architecture. Okay, SOA. SOA. You know SOA? Have you heard about SOA? Yes? Yes or no? Yes, give me what a no, a lot of you know, do know, Service oriented architecture mean you each of URL, okay, provide certain service, and then you can access this through either, for example, using SOAP protocol, SOAP, okay, SOP, or using REST protocol. You know where to get a particular service. Then you call the API, and then it give you that kind of service. So you can call a program according to their services they provide. So from the oriented architecture, actually they are using service broker and so on. And today evolved into Web 2.0, Web 3.0, and evolved into, for example, now you can call cloud services also service oriented. You can infrastructure as a service and so on. You can call them, but they are towards the users. But service oriented architecture more towards programmer, developer can call particular service. For example, you want to access to a certain API to see the chart, okay? Example, oh, each time I give my lecture, not necessarily based on the PowerPoint, a lot of new concept coming in. So then you will learn new thing as well. So these are important, like service oriented architecture. So SOA, what is SOA? So these are quite old concept. You can see what is service oriented architecture, but these are quite old concept. Okay, and then you evolve. Okay, so you can have a look and so on. For example, I'm using for example, let's say I'm type something. Let's say I am type a particular say uh US dollar, US dollar index. Okay, US dollar index, then uh For example, trading view. Okay. Okay, so when I click US dollar index, then I can see the chart like that. Okay. For example, I see this chart. So, and trading view are very popular. Then it give a lot of people can call this chart within that program. So you don't need to come to this URL only, you can see the chart. Then you can use your own program to call the API to plot the chart. So in order to do that, then you need to know how to call the chart and what will it return. So when you know that this is called program API, and this API is called service. Okay, so you know the service. What is the service of this program provide? This program provide you a chart, okay, for you to see the chart. So when you can see the chart, so actually you are using the service. You are using the service to plot the chart. These are example of calling service-oriented architecture. So everything is based on service. Whatever program you need, you can call them. Okay, and when we access to URL, when you access to URL, normally it's for human being that you read HTML. But when you this one, the web can become, instead of for human being to read them in HTML, you can read them in XML or whatever that machine can call them. Machine can understand the message, and machine can do a program. So for example, you can have exchange rate, you convert something and so on. Actually, it's not a fixed page, but it can accept parameter. Okay, for example, Google here. Let's say I want to say I want just now the instead of C dollar fixed URL. So I say dollar to ringgit. Okay, so when I dollar to ringgit, for example here, I say $1 is equal to 4.23. I say, and then I key in $3, then it gives me 12.6 and so on. So these are services. These are no longer a fixed HTML. You go to call a program, and program return back XML or whatever, and then it display it. Okay, so here already is a services. Okay, what Zhang Tao know? Oh, you all say no about service-oriented architecture. Okay, so now do you understand me? What is service-oriented architecture? Call everything by services. Understand me? Give me two. No. So if you understand, these are called service-oriented architecture. They are, of course, in order to achieve that, you need a lot of levels and to do that. But mean you can call your program as a services, like a function call. Okay, like a function call. In that case, these are more towards data parallelism or task parallelism. Data parallelism give me 1, task parallelism give me 3. Service-oriented architecture, is it task parallelism or data parallelism? 1 or 3. Data is 1, and task is 3. Hello? You know, no, do not give me 0. Do not give me 0. 0, 1, or 3. Okay. Some say 1, some say 1, some say 3. The answer should be 3, because I call the service, each of them do a particular service. When you do a particular service, means it do a particular job, it do a particular task. Okay, so it do a particular task, I can call Now, let's say I want to carry a series of tasks. So I can call the server for me to execute exchange currency. I can call another machine to see the dollar index. I can see the dollar convert to ringgit, dollar convert to yen, dollar convert to many currency, and then I see the chart. Now I can use a program to write hyper trading for forex to execute the forex. How to say, to buy forex, to buy or sell, and then I use a program to call all these services in parallel. Each of the server execute different thing for me. Now I want to see the currency happen. Is it in US dollar? How much in Malay ringgit? How much, and so on and so on. Then I try to find the gap, any opportunity for me to invest. Okay, and I also can see different dollar index trade and so on. So that is called task parallelism, because every machine, they will execute different tasks for me. It's not data, same data, different services run on different computer in the same time. It's called task parallelism. Do you understand that? Understand? Give me one. Don't understand? Give me zero. So you should answer correct. So just now a lot of you still answer wrong answer. You say data parallelism. It's not data parallelism. Okay, it's a task parallelism because they are execute different tasks. Okay. Okay. Now let's say for example, they are one of the program executing, for example, uh, calculation. Okay, they are doing one service only. Okay, one service only. These are calculate the faster road from USM to let's say to Gurney Drive, to one of the destination from USM to Gurney. Let's say from USM to Gurney, or USM to Kuala Lumpur. Let's say from USM to Kuala Lumpur. Okay, which part of Kuala Lumpur? Let's say USM to Putrajaya. Okay, USM to Putrajaya. I want to know the shortest path. Shortest path from USM to Putrajaya. Shortest path. Okay, and then you send uh, this request to a service, and this machine are how to say it are executing behind in parallel to in order to get this uh, request done. Okay, and give you very quick result to that. Can you know what kind of parallelism that done behind? Is it task or data that do behind in order to give you the shortest path? Okay, can you know whether it's execute data parallelism or task parallelism? Okay, so for example, in this kind of scenario, it's not clear. It's not very clear because we didn't know behind how it write the program to calculate the shortest path. Okay, sometimes it's not very clear, so we can't tell. Okay, for example, let's say a more clearer example is let's say you want to do a training. Okay, I give training for the program to recognize Dr. Chan face. Dr. Chan face. So I take 100 picture of my face and train the computer 100 picture. Okay, and then I send this 100 picture to the computer to face recognition for training. Is it use data parallelism or task parallelism? So that it can run faster. Okay, data or task? Okay, data, right? This time is correct. Data parallelism. Okay, so from here, then later, once you know this concept, then you can write your parallel program. You can write parallel program. If you don't know this concept, you're difficult to write a parallel program. These are the most basic concept. Okay, once you know that, then you can play with them. You can mix. Okay, you can mix. Okay, so these are example. Division of tasks, data, division of tasks. Okay. Okay. If a program is inherently sequential, adding more processor will not improve performance. Okay. The existence of non-parallelizable computation limit the potential benefit of parallelization. Under law. Okay. Meaning you sometimes you can executing in parallel, sometimes you cannot executing things in parallel. Okay. For example, what thing you cannot execute them in parallel? Do you know what? Code is not always that you can execute them in parallel. For example, let's say I giving you lecture. Okay. But if I'm talking in parallel, for you it's meaningless because I reverse the order is not important. I can say A, B, C. Now I say CBA, BAC, and if I say if a program is inherent sequential, but if I talk in parallel, then I can say the existent problem, adding more under law parallelization sequential. I say something all mixed around, not in order, then you don't know what I'm talking about. Because you need the order so that you can have a logic. So in that sense, sometimes is you cannot executing in parallel because you want to maintain the order. It's important. So once you want to maintain the order, so you cannot put it in parallel sometimes. Okay, and sometimes in parallel, if you need to have concurrency control. If you don't have concurrency control, it will produce inconsistent data. For example, let's say I use a transfer money, you can only assess your balance. One process can assess at a time. You cannot allow multiple access at a time. Then the bank will lose a lot of money because he didn't lock the critical section your balance. Okay, so it will the data raise problem. So the user can withdraw the money many times, even with the same amount, then the bank will lose money. Then you become millionaire. The time I use an example. For example, another example, let's say now after COVID-19, a lot of people want to go out, want to travel. Like I see the newspaper, okay, the Mata Fair. I mean, Mata Fair is the for people to go travel. Usually they have this exhibition fair, then they have a lot of promotion. Okay, if they don't have concurrency control for the air ticket system, then many users can book the same ticket, same seat, same trip. Okay, let's say I want to go to Singapore using Malaysia Airline next month for holiday. Okay, so I buy the ticket, I book the ticket, it give me the same time, and then I put the seat, let's say 10A, I get the seat 10A. Okay, if I don't have concurrency control, the other person will buy the same seat for and same time and so on, also 10A. So I go there to the airport, then I discover my ticket and his ticket the same. Why? Because they don't have concurrency control. It's called overbooking. Overbooking because they don't control it's only can allow one person only, but it allow few person access the system same time, then they do the booking same time. It's called overbooking. Okay, you see the problem. So this thing is cannot everything execute in parallel because you need to have some kind of control synchronization, some kind of control for the order. ordering, okay, and so on and so forth. So you need to maintain sequential things. It's called non-parallelizable. And this non-parallelizable is big, very big, your program. Then if you have multi-core or multi-CPU, you also cannot benefit because you need to execute A first, then B. Execute B first, then C. Okay, then you cannot send A, B, C together and run because the result of the A will channel to the output for the B. The output of the B will be the input of the C. Okay, in that sense, if the order is very important and the one of the process dependent on the other process, then you need to maintain the sequential. Okay, if the bigger portion this program, then your code will become cannot be execute very fast. Even you have a lot of very high speed machine and so on. Okay, so you because your program cannot run in parallel. So this one is designing parallel program. So first coordination. Core usually need to coordinate their works. Communication, one or more cores send the current partial sum to another core. The other one is load balancing, share the work evenly among the cores so that one is not heavily loaded. And then synchronization, because each core work at its own pace, make sure core do not get too far ahead of the rest. Okay, so these are example of coordination. You have three component, three things that you need to concern: communication, load balancing, and synchronization. Okay, communication you need to send to each other's. How to you when you communication? Why you need communication? Because you need to divide and conquer, either by data parallelism or task parallelism. So when you do data parallelism, you need to send different data set running on different computer. When you do task parallelism, you need to call different server, different computer to do different jobs. So you need to call mean you need to invoke mean you need to send your request from computer A to computer B. This involves communication, either by your command as a for the task or by sending with different data sets, sending the command with different arguments. Okay, load balancing. Okay, so one of the machine is overload, then you don't go there anymore. You go to different computers. For example, now you can run Kubernetes. For example, it's popular for to run the Docker container and so on. So when you want to schedule your job to different working nodes, which is underloaded, then you run your kubelet, okay, with container there. Okay, if your certain working node are heavy already, many container running there, then don't run the same don't run the new container again in the same working node because it's overload already. Maybe 80% use, the other only 20% use. Then go to 20% use because you still under power and under utilization. You only use 20%. So for example, same in the company. If you have one worker, no job to do, very idle, do nothing, and the other job, the other person overload, work until here already, need to work overtime and so on. Then you further ask him to do the job, then he will create call not justice, not fair. Then if you pay him the same salary to the other person, this person will leave because he feel not fair. This happened to the person, the company. Same thing in the machine. Same thing happen. Okay, if their machine are same performance, same gigahertz, same CPU, same RAM, and then one get 80% job, the other only 10% job. Why not send the other job, send more job to uh, light node machine? So these are the concept called load balancing. Then you will be execute it more efficient. synchronization. Okay, because synchronization, as I say, you sometimes you need to maintain the order. You need to until one job finish, then only you can continue other jobs. So you need them to synchronize. Okay, so I think almost 7:30, so we go for a break. We continue at around 8 o'clock. Okay, so break here. Okay, for those that Muslim, selamat buka puasa in Malay, mean you wish you a good open your break, open fasting. Okay, see you.